So good afternoon everyone. Today is the last class for solid state physics. So today we are solving the last week's problems and some other problems also. And yesterday I have taken one class around 1 hour, that is a concluding class actually, and the overall view that you can get it in the NPTEL portal. The link you can get it, go through it, okay, once for before your exam. That will be important for you. So let us go to the first problem. First few problems are like every day we are doing it with small theory problems. So choose the correct relation between the polarization vector and electric field vector. Okay, so the answer that we all know already, it is a basic theoretical question. So the answer is P is equal to epsilon 0 into epsilon r minus 1a. Okay, next question. The value of the capacitance of a parallel plate capacitor in air medium is 10 microfarad. If the spacing between the two plates is completely filled with a dielectric material having dielectric constant epsilon r is equal to 10, then the value of capacitance. The options are decreased to 1 microfarad, increased to 20 microfarad, increased to by 90 microfarad. Does not change. The answer will be increased by the 90 microfarad. Okay, so how to get it here, like the C0 value, that is 10 microfarad. Okay, epsilon r, that is 10. C by C0 is equal to epsilon r, right? So C is equal to epsilon 0, it means epsilon r C0. So you will get it 10 microfarad into 10, so it will be 100 microfarad. You will get it, so increased by the 90. So that's why we have to get the answer for this question. Now let us go to the next one. Electronic polarization. That answer is independent of temperature. Even answers are wrong. Okay, so the ionic polarization is independent of the temperature, and the orientational polarizability alpha 0 decreases with increasing temperature, and the dielectric loss occur in the dielectric material is subjected to AC voltage. Okay, so these are the answers. Now let us go to the problem section, that is more important. Okay, so see the question. Assuming the atomic polarizability of a krypton atom is 2.2 into 10 to the power minus 40 farad meter square, calculate the dielectric constant of krypton at STP, that is at temperature 0 degrees Celsius at the pressure of a 1 atmospheric pressure. Okay, so Avogadro number is given. So everything whatever you have studied till now in the solid state physics is almost everything based on the general formula. So please listen this our class carefully, note down all formulas. So all these kind of formulas only, it's just like a direct application of formulas, you will get the problem. So here the alpha value, it is given 2.2 into 10 to the power minus 40. Okay, so then epsilon r of krypton in STP, that you have to calculate. Okay, so you have to use Cauchy-Mazotti equation. So epsilon r is equal to 1 plus 2n alpha divided by 3 epsilon 0 divided by 1 minus n alpha divided by 3 epsilon 0. So n value, number of atom per unit volume. So at STP, how we can calculate n value? N value is equal to 6.023 into 10 to the power 23 divided by 22.4 into 10 to the power minus 3. Okay, so you will get the n value here, that is 0.27 into 10 to the power 26 per meter cube. Now we have to calculate that n alpha divided by 3 epsilon 0, substitute all the values and find the value. From there you have to calculate the epsilon r. So you will get 1 in plus 2 into n alpha, means 2 into this answer whatever you are getting here, divided by 1 minus the answer. Okay, then you will get the epsilon r value. So please find it, then let me know. Please keep it in the chat box what will be the answer. Okay, solve it and keep it in the chat box. So here in alpha by 3 epsilon 0 you will get the value 0.0223 into 10 to the point minus 10 to the power minus 2, and you will get the epsilon r value, it will be 1.0007. okay, so that will be the answer. Now let us go to the next problem. Calculate the average radius of a atom for one of the air molecule, say nitrogen, if the electronic polarizability to atom is alpha is equal to 10 to the power minus 42 coulometer per volt. Okay, so how to find it? You have to calculate the R average. Okay, so alpha E, that will be 10 to the power minus 42 kilometer square divided by volt. Okay, now alpha E formula we know that it is 4 pi epsilon 0 R average cube. Okay, so R average cube will be alpha E by divided by 4 pi epsilon 0. Okay, then R average will be alpha E divided by 4 pi epsilon 0 whole power 1 over 3. Now just substitute all the values, that's it. So 10 to the power minus 42 divided by 4 into 3.14 into 8.85 into 10 to the power minus 12 whole power 1 over 3. So do this and you will get the value of R average. So here you will get the average values here 2.08 into 10 to the power minus 11 meter. Okay. So we'll move to the next one. The electronic polarizability of for a given gas is 3.5 into 10 to the power minus 14 farad meter square, and at STP the concentration of the gas molecule is 2.7 into 10 to the power 23 per meter cube. Calculate the value of its dielectric constant at STP using the Closius-Mozart equation. So it's just direct formula, you have to just use it. So alpha E value and alpha E value which is given 3.5 into 10 to the power minus 40, and N value that is given 2.7 into 10 to the power 25 per meter cube. Okay, epsilon R you have to calculate. Okay, so first similarly like earlier problem, n alpha by 3 epsilon 0, first you calculate, then substitute in the epsilon R Closius-Mozart equation 2 into value divided 1 minus n epsilon. Okay, that's it. So just I'm giving 2 minutes, just try it and let me know the answer. So here you will get the answer 0.3559 into 10 to the power minus 3, and substitute that values here. You'll get the epsilon r 1.001. Okay, so this will be the answer for this question. Now let us move to the next question. So that is, if NaCl crystal is subjected to an electric field of 10 to the power 2 volt per meter and density of polarization, that is number of induced dipole moment per unit volume P, that is given 4 into 10 to the power minus 10 farad per meter square, calculate the value of dielectric constant. Okay. So the electric field which is given 10 to the power 2 volt per meter. Okay, the polarization P is equal to 4 into 10 to the power 10 farad meter square. Okay, then epsilon r we have to calculate. So P polarization formula we know, epsilon 0 chi e, right? From here you calculate chi e value first, that will be P divided by epsilon 0 e. After getting chi e value, you can calculate the epsilon r, that will be 1 plus chi e. Okay, just substitute the values and let me know the answer, how much you are getting. Okay. So you will get the answer chi value will be 0.45. Substitute all p value and epsilon value, then you will get the epsilon r value 1.45. okay, let us go to the next problem. Determine the percentage of ionic polarizability in sodium chloride crystal which has the optical index of refraction and the static dielectric constant as 1.5 and 5.6 respectively. Okay, so dielectric constant value which is given, that is 1.5, that means it is n. Okay, then 5.6, that is epsilon r. Okay, now use the closed density equation. So epsilon r minus 1 divided by epsilon r plus 2, that is equal to n into alpha e plus alpha I divided by 3 epsilon 0. Alpha I means electronic polarizability, alpha I mean ionic polarizability. Okay, now the optical frequencies, if you know, then equation, and this we can call equation 1, then equation 1 will be become, we can write it as n square minus 1 divided by n square plus 2 is equal to n alpha divided by 3 epsilon 0. So that will be equation 2. Okay, now divide equation 2 with equation 1. Okay, so you will get n square minus 1 divided by n square plus 2 into epsilon r plus 2 divided by epsilon r minus 1, that is equal to alpha e divided by alpha e plus alpha I. Okay, now fraction of electronic polarizability. So this fraction we can write fraction of electronic polarizability. So then it will be like, we can write alpha e divided by alpha alpha e plus alpha I, that is equal to into 100%. Okay, that is equal to 1 minus alpha e divided by alpha e plus alpha I into 100. Okay, now substitute all the values. So we have to alpha e, we have to substitute this formula here. So it will be like 1 minus n square minus 1 divided by n square plus 2 into epsilon r plus 2 divided by epsilon r minus 1, okay, into 100. Okay, substitute all the values, you will get the answer for this. So we will get the answer 51.4%. Okay, now let us go to the next one. The optical index of refraction and the relative constants of water are 1.33 and 8.1 respectively. Determine the percentage of ionic polarizability. Okay, so here n is equal to 1.33 and epsilon r is equal to 8.1. So percentage of ionic polarizability, that is I alpha I divided by alpha I plus alpha E into 100, that is equal to 1 minus alpha E divided by alpha E plus alpha I, okay, into 100. So that will be like, we can write it like earlier, n square minus 1 divided by n square plus 1 into epsilon r plus 2 divided by epsilon r minus 1 into 100. Okay, so that we can write it as, substitute all the values. So 1.33 square minus 1 divided by 1.33 square plus 2 into 8.1 plus 2 divided by 8.1 minus 1 into 100. Okay, then you will get the answer for this. Find it out. So here you will get the answer 71%. Okay. So let us go to the next one. Calculate the polarization of a BaTiO3 crystal. So the structure transformed from the cubic to tetragonal below the Curie point with lattice parameters C and A are equal to 4.03 angstrom and 3.98 angstrom respectively. So the displacement of titanium ions is opposite to that the oxygen ions. The magnitude of the displacement is 0.06 angstrom for titanium and 0.06 angstrom for oxygen ions on the side faces and 0.08 angstrom for the oxygen ions on the top and bottom faces of the cube. So then the displacement of the barium ions may be neglected. Okay. So okay, so it is given A equal to B, that not is equal to C, and A equal to B, that is equal to 3.98, and C is equal to 4.03. Okay, now the displacement. So P value we have to calculate epsilon Q I D I. Okay, so P value will be what? 2 into half into minus 2 electron into minus 0.08. That's for the oxygen inside phases. Okay, means oxygen top and bottom, plus similarly half 4 into half into minus 2 electron volt into 0.06, that phase sides. Okay, top, this is top bottom O2 minus top bottom, and this is for corresponding to the side. Okay, then plus which atom, 1 into 1 plus 4 electron volt into 0.06, this for the TII 4 plus atom. Okay, so now total you will get it 2e into 0.08 plus 4e into 0.06 plus 4e into 0.06. So you will get the total polarizability here, means p value, that will be 0.64 into 1.6 into 10 to the power minus 29 kilometer. So the polarization p value, it will be dipole moment per unit volume, right? So that will be p divided by volume of unit cell. Now volume of unit cell will be A, B, C, it will be A square B here. So you will get the answer, you substitute everything. Okay, then now let us calculate the polarization value. So it will be like 0.464 into 1.6 into 10 to the power minus 29 divided by 3.98 into 3.98 into 4.03 into 10 to the power minus 30. Okay, then you will get the answer. So 0.16. Okay, now let us go to the next problem. The critical magnetic field HC 0 and the critical temperature Tc of a lead are 7.7 into 10 to the power 4 ampere per meter and 7.2 Kelvin respectively. What is what temperature it must be cooled to become a superconductor in a magnetic field? HCT is equal to 2 into 10 to the power 4 ampere per meter. Okay. So here HC0 value that is given 7 into 10 to the power 4. Okay. And Tc that is given 7.2. Now we have to calculate T. It's C of T that is given 2 into 10 to the power 4. So we know the whole formula already. HC of Tc. This is very important one. Okay, you have to remember always. Into 1 minus T divided by Tc whole square. Okay. From here you have to calculate T. T will be formula Tc square. You just rearrange it. Okay, 1 minus Hc of T divided by Hc of 0 whole power 1 over 2. Substitute here, you will get the answer for Tc. here. First to all the values, you'll get the answer 6.08 Kelvin. Okay. Now let us go to the next problem. The transition temperature of a mercury with an average atomic mass of 205.59 AMU is 4.153 Kelvin. Determine the transition temperature of one of its isotope Hg, that is 80204. Okay. So here we have to know the one thing, that the transition temperature of a superconductor is related to the isotopic mass, right? So then it will be Tc, that is proportional to I by 1 by root m. Okay, so then Tc2 divided by Tc1, that is equal to root m1 divided by m2. Then Tc2 is equal to Tc1 root of m1 divided by m2. So that will be 4.5153 into root of 200.59 divided by 204. Then you will get the Tc2 value. Okay. how much you have got answer here? It will be 4.118 Kelvin. Okay, now let us go to the next one. The critical temperature of a superconductor at zero magnetic field is Tc. Determine the temperature at which the critical field become a half of its value, 0 Kelvin. So here also like similar problem, similar kind of problem only here also. So this will be the answer. Okay, please note it, then we will move to the next one. Okay, now let us move to the next one. The critical field at 6K and 8K for NPTEL alloy are 7.616 and 4.284, okay, respectively. Determine the transition temperature and critical field at 0 Kelvin. So here HC of 6K, that is 7.616. Similarly HC of 8K, that is 4.284. it is given. TC we have to calculate, HC of 0 we have to calculate. Okay, so HC of T we know that formula already. So take the ratio of it. So HC of 6K divided by HC of 8K, that is equal to 1 minus 6 divided by TC whole square divided by 1 minus 8 divided by TC whole square. Okay, then 7.616 divided by 4.284 is equal to 1.77. So from there we can do 1.77 minus 1.77 into 8 by TC whole square is equal to 1 minus 6 divided by TC whole square. Okay, then it will be HC of T you calculate. From there HC of T formula, from that you can calculate that it will be like 7.616 divided by 1 minus 36 divided by 100, so it will be like 11.9. that will be the answer. Note it down, then we will move to the next one. Now let us go to the next one. Determine the frequency of the recombinant wave radiated by a Josephson junction across which a DC voltage of 0.0 millivolt is applied. Okay, so here frequency is frequency of electromagnetic radiation by a Josephson junction across the voltage we have to calculate. So the frequency, that is very easy formula, 2 EV divided by H. So that is 2 into 1.6 into 10 to the power minus 19 into 0.5 10 to the power minus 3 divided by 6.626 into 10 to the power minus 34. So you will get the answer 2.41 into 10 to the power 11 hertz. So that will be the answer for this. It's very simple question, but you have to just remember, you will get the mark for this question. I hope all of you noted these questions. Now let us go to the next set of questions. Okay, so see here, A paramagnetic salt contains 6.4 into 10 × 28 ions per meter cube, and the magnetic moment of each ion is 1.4 Bohr magnetons. The salt, which means the sample, is placed in the uniform magnetic field strength H is equal to 5 into 10 to the power 6 ampere per meter at temperature 500 Kelvin. So calculate the paramagnetic susceptibility according to the Langevin classical field theory of paramagnetism. Okay, so mu b value and kb constants value is given. So how to solve it? So here n value that is given 6.4 into 10 to the power 28 ions per meter cube, mu m value that is 1.5 mu b, so that way I can calculate, and h value that 5 into 10 to the power 6. So susceptibility mu b n mu m square divided by 3 kBt. Okay, so it will be 4 pi into 10 to the power minus 7 into 6.4 into 10 to the power 28, 1.5 into 9.28 10 to the power minus 24 whole power square divided by 3 into 1.38 into 10 to the power minus 23 into 500. So you will get the answer 7.51 into 10 to the power minus 4. So that will be the answer for this question. It's just applying the dead formula. Next, go to the second problem. So, susceptibility of a paramagnetic metal at 300 Kelvin is 7.5 into 10 to the power minus 5. At what temperature susceptibility increases to 2.5 into 10 to the power minus 4. Okay, so here we know that susceptibility which is proportional to 1 over T, or chi proportion equal to C over. Okay, then chi of 300 divided by chi of T, that is equal to C divided by 300 divided by C divided by Ct, Ct, then 7.5 into 10 to the power minus 5 divided by 2.5 into 10 to the power minus 4 into T divided by 300. Okay, so you will get the T value, that is equal to 7.5 into 10 to the power minus 5 into 300 divided by 2.5 into 10 to the power minus 4. Okay, then I indicate. Let us go to the next one. Assume that a magnetic dipole having moment 1.5 Bohr magnetrons is aligned parallel to an external magnetic field of strength 1.5 Tesla. Calculate the energy required to turn the magnetic dipole so that it is aligned in anti-parallel to the field. Okay. So the orientation potential energy when the dipole is parallel to the field is minus mu Lb, and it is plus mu Lb when it is anti-parallel to the field. So that energy that must be supplied to the dipole is total 2 mu Lb. Okay. So 2 mu Lb is equal to 2 into 1.5 mu B into 1.5. Okay. So it will be 2 into 1.5 into 9.23 into 10 to the power 27 into 10 to the power minus 24 into 1.5. So you will get the answer 4.17 into 10 to the power minus 23. Okay, that will be the answer. Let us move to the next question. The sodium metal having BCC crystal structure and its average atomic radius is 1.854 angstrom. Calculate the diamagnetic susceptibility for a sodium metal. Consider per atom provide an electron that contribute to diamagnetism properties. Okay, so here BCC crystal structure for edge length of the unit cell, that will A is equal to 4 by root 3 r. Okay, so it will be 4 by root 3 into 1.854 into 10 to the power minus 10. So it will be like 4.28 into 10 to the power minus 10 meter. Okay, now the number of atom contained per cubic meter sodium metal, that NET will be number of atom per unit cell divided by volume. So n number of atom in the units of BCC, so it will be 2, then 4.28 into 10 to the power minus 10 whole cube. Okay, then you will get the answer 2.55 into 10 to the power 28 atoms per meter cube. Now atomic number of the sodium, that said is equal to 11. So by diamagnetic, that is equal to minus mu 0 Z E square n R square divided by 6m. Okay, so m mass is given, substitute all the value, minus 4 pi into 10 to the power minus 7 into 11 into 1.6 into 10 to the power minus 19 is square value, and n value we have found, that is 2.55 into 10 to the power 28 into 1.85 into 10 to the power minus 10 square whole divided by 6 into 9.1 into 10 to the power minus 31. So you will get the answer minus 5.68 into 10 to the power minus 5. So that will be the correct answer. Now let us go to the next problem. Estimate the order of a diamond susceptibility of a copper having FCC crystal structure, and consider that only one electron per atom makes the contribution of its diamagnetic property. So the radius of a copper atom is given, and the lattice parameter which is also given. The same formula you have to use here. So here the first you have to calculate the n value, 4 divided by a cube as usual. Then you will get the 8.5 into 10 to the power 28 atoms per meter cube, and Z value is 29, and chi diamagnetic, and it will be minus mu 0 Z E square n R square divided by 6m. Substitute all the values, you will get the answer minus 2.09 into 10 to the power minus 4. Okay. Let us go to the last problem. A transformer core is wound with a coil carrying an alternating current with a frequency 50 Hz. Assuming the magnetization should be uniform throughout the core volume of 0.02 meter. Calculate the power loss due to hysteresis. The hysteresis loop has area of 10.5 units and 10 power 5 units. Okay, when the axes are drawn in units of 10 to the power minus 4 rubber per meter square, and the 10 square ampere per meter. Okay, so the energy loss per unit volume during each cycle, that will be area of the loop. So 2000, what will be the answer for this question? So okay, so these are the problems for your exams and also all the rest for your exam. Save and follow such class, and all the equation you should remember, and very little theory problem will be there, more mathematical problems will be there. So please go through all the problems whatever we have done in the classes, and as well as are solved in the classes. Okay.
So please, ma'am, take extra class for type of examination, pattern of examination, इसका बारे में.
That will be same like your assignment, same kind of only, multiple kind.
So any theory?
Theory will be like not a written kind of, but little bit, like just you can get it from the SARS class. If you are following that properly, you will get it from that. That's it. No, like external things won't come.
Okay.
Okay, now I think I have taken 12 week class plus yesterday 1 hour extra. So there will be 25 hours class already done. So please go through the problems. I have solved more than I think 20 to 23 problems.
Okay, ma'am. This today's class notes link में आप कुछ कर दीजिए.
Already the link right from the NPTEL forum. I think from the drive you are getting already. So I will upload it now. You will get it soon. Okay.
Okay. Thank you. Thank you very much.
You're welcome. So all the best.